Now I start recording second videos. So find the minimum and the maximum number of nodes between critical points. The critical point in a linked list is defined as either a local maxima or local minima. So a node is a local maxima if the current node has a value strictly greater than the previous node and next node. Okay, so the current node, okay, a node local maxima is current node has value straighter smaller than the previous node and next node. No copy only one. Okay, so you can go through this question. The question of I will talk about this example and my idea. So let me 5 3 5 3 1 2 5 1 2 5 and 1 2. So here the question say, so local maxima is the current node has a value straightly greater than the previous node and the next node. So you can see in the example. So and then the second root node local maxima is the current node has a value straightly smaller than the previous node and the next node. I think it's really easy to understand, right? Easily to understand. Then here you can see in the example. So I just draw this example in my node, which can help easier to help people to understand the question. So how to find it? So actually, it doesn't need an arrow. Let me remove it. So now you can see the explanation. Here are three critical points. So you can see one. One is next than the previous node and the next node, right? So it's local maxima because one is here already told us, right? Next here five. Five is greater than his labor, 2 and 1. So it's 2 is 5 and 1 is next name. It's easy to understand, right? Just use this way. This one. Now here we can see node and node can be maximum here. So we need to know what we need to return as output. So here say it's array of length to contain a minimum distance and the maximum distance. The first minimum distance is minimum distance between any two distinct critical point, and then so maximum distance is the maximum distance between any two. So how to find the distance? It's easy, right? So before, so first we know here is our here is the local maxima, right? Because one is the, so you can assign in there 0. No, here should be start from 1 2 3 4 5 6 7. So why we start from 1? So you can see an example. So here's, you see here is 1. You see here using a third node. So here, so that's why here's 1 2 3. Now index 3, 1 assigned to index 3, right? So that's why here, so we know we got the local maxima, and here maxima and the because 5 greater than previous node and next node, and here 1 is next name the local minimum, right? So now here we got a 3 in there. So how to know the maximum distance? It's easy one, right? The first last this in that last in there minus the first in there, so we will get the maximum distance. It's very simple, right? See, I previous video already told this one. So here we got a 3. Now, how to get the minimum? So the minimum is a little bit, we need to compare each two because we don't know what is the distance, how far the distance from current node to the previous node. We don't know, right? So we need to compare each two node, and then now here 5 minus 3 equal to 2. Okay, now the minimum distance 2. Now we go to next one. Go to next pair. So now 6 minus 5, we got 1. So we need to find the minimum distance, right? So here we use this one, and here this maximum. So finally we return, because minimum distance should be assigned to the first parameter, and then 3 is in the second parameter. So that's why it return 1 and 3. So this question is pretty simple. We only know how to get the minimum distance and the maximum distance like that. Now quickly go through the coding. So here I use the here the head that one is the previous node. So because I want to start from 3, so that's why I assign the head that value to the previous node, and then the pointer will point to the 3. That's why here I start from 2. Now here is maximum difference. Now here just check and then next node, not equal to node. If we equal to node, we know we already reached the end of linked list. We need to break the while loop. Otherwise, we need to keep processing this linked list. And then we to check. We have two conditions, right? We need to if the current the header value greater than previous, so the current value greater than previous value, and also need to check the next value if the current value greater than both value. So we need to add an index to the list. So why I use the array list here? Because we need to store. Oh, sorry. Oh, we don't need to use the array list. Sorry. It's not necessary. Okay. Okay. So we can keep it here, but I would say we don't need to. We don't need to use this one. If I use this one, they will use HR memory. So why I use here? Because here the first solution, first time. Wait, what's the coding? Actually, you don't need to care about this one. How to get my default? Okay, so I would say doesn't use it, but right now you can use it because I before this first time I submitted, I used the linked list to find the minimum. Actually, it doesn't need it. Actually, it doesn't need this way because I never will tell HR memory. So but it's fine. But it's fine. You can use it. So here, use it, and now we just we need to get in there, right? We need to get in there for each the minimum distance, minimum a local minima and the local maxima, right? So we need to know where is the precision. Now, when we finish this one, we need to assign the current value to the previous because we need to comparing, right? Now, here's because we need to move to next node and I plus. Now here, if the list size less than 1, we know here in the question already told us. So it's field length 2 critical point, so which return -1, -1. So you can see here. Now here we use the we need to get maximum distance, right? So here just get the last index and the first index just subtract. So then we will get the maximum distance. And here minimum distance here, which compare each two previous index. The current index minus previous index, we will get we need to comparing which one is the, we need to get the minimum distance, right? So natural we need to comparing to know, and then we will get the minimum distance, and then here to return it. So you can see already pass, but here it's not efficient way. Maybe you can check other people's solution, but it's my solution. So that's why the time complexity is b of n, because I only run the linked list only once, and the space complexity is b of n because I use the extra linked list. Actually, it doesn't need to use this one. I forgot to delete this one actually because it's my first idea. So I didn't go to optimize my solution. So I would say right now I realize that the need to use this one is fine. So you just use some variable to key track of the previous node and the last node like that. Now thank you for watching this video. I taught a lot here.